going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. Now you see, of course, that with this method we can disprove any definite theory. If you have a definite theory, a real guess from which you can really compute consequences which could be compared to experiment, then in principle we can get rid of any theory. We can always prove any definite theory wrong. Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong. Because in the future, there could be a wider range of experiments, you could compute a wider range of consequences, and you may discover then that the thing is wrong. The theory had been failed to be proved wrong and could be taken to be temporarily right, but it can never be proved right because tomorrow's experiment may succeed in proving what you thought was right wrong.
Asimov was a great writer of fiction and non-fiction, science and science fiction. He received a letter from a non-scientist who wanted to correct his attitude about science. I'll quote him. "Every century, people have thought they understood the universe at last, and in every century they were proved to be wrong. It follows that the one thing we can say about our modern knowledge is that it is wrong." My answer to him was, "John, when people thought the earth was flat, they were wrong. When people thought the earth was spherical, they were wrong. But if you think that thinking the earth is spherical is just as wrong as thinking the earth is flat, then your view is wronger than both of them put together." The basic trouble, you see, is that people think that right and wrong are absolute, that everything that isn't perfectly and completely right is totally and equally wrong. Once people believed the earth was flat, and they were wrong, but they were also very nearly right. The curvature of a flat surface is 0, and the curvature of the Earth's surface is very nearly 0, to a certain level of approximation, the kind of measurements the ancients were capable of. After some rather brilliant observation by great scientists such as Aristotle, the basic idea of a spherical Earth was advanced, and measured a century later by the Greek philosopher Eratosthenes, by noting the difference in shadow lengths at different latitudes. We thought then that the Earth was a sphere, and that the actual curvature of the Earth must be 0.00126 per mile, a quantity very close to, but not quite equal to 0. This difference was important in our ability to make accurate maps and sail great distances without missing our destination. So then we thought the Earth was a sphere, but that was also wrong. Based on observations of the other planets, Newton showed that rotating masses are very slightly flattened at the poles. Scientists measuring the Earth very precisely, using newer instruments, were able to determine the degree of oblateness, the measure of departure from a true sphere. The correction in going from spherical to oblate spheroidal is much smaller than going from flat to spherical. Therefore, although the notion of the Earth as a sphere is wrong, strictly speaking, it is not as wrong as the notion that the Earth is flat. What actually happens is that once scientists get hold of a good concept, they gradually refine and extend it with greater and greater subtlety as their instruments of measurement improve. Theories are not so much wrong as incomplete.